Today we're just going to take the opportunity to do a little bit more practice on the hypergeometric distribution and really get the idea before we move on. So I'm just going to do 3 more examples and give you another worksheet so you can practice this some more. If we have 5 green and 45 red marbles in a jar, then we're going to close our eyes, we're going to randomly draw 10 marbles, but we're not going to put them back in the jar as we take them out. So the probability that exactly 4 out of the 10 are green, that means that from the green marbles, the 5 green marbles, we want to choose 4. So we're going to go to that pile of green marbles and we're going to choose 4 out of the 5 of those. But we have to choose 10 marbles. So that means that the rest of our marbles have to come from the group of red marbles, and there's 45 of those, and we're going to choose 6 so that we have 10 marbles selected. If we want to make this a probability, because we've just calculated the number of ways right now, then the probability of 4 green is going to be that over the total number of marbles, which is 50, and we're choosing 10 from that. And so that's all the ways to randomly just choose 10 from a group of 50, regardless of the color. I like these questions because you can think about what the outcome is going to be, and you can really look at your answer and decide if it makes sense or not. And so looking at this and wondering what's the chance that we get 4 out of our 10, so 40% of our marbles are green, when there's only 5 of them to choose from out of a total of 50, we know that that probability is going to be low. And it turns out that that probability as a decimal comes out to 0.00396. And the reason that I kept that many decimal places is now I'm going to change it to a probability as a percent. I'm going to move my decimal 2 places over, so I have 0.396% chance, not even a 1% chance of this happening. In this example, we're choosing a team of 8, and we have 23 players to choose from. And so in this case, what distinguishes some of the players from others is the position that they play on the hockey team. We have 13 forwards, 7 defensemen, and 3 goalies. So in part A of this question, we're being asked to figure out the probability that we end up with 3 defensemen on the team. We have 7 defensemen, and we need to choose 3 of them in order for that to happen. That means out of our 8 players, we've already got 3 chosen. And so we're now going to choose 5 from the remaining players. None of the rest can be defensemen. And so we have only 16 left to choose from for the remaining 5 players. If we want to turn this into a probability, then we look at the total number of ways of choosing 8 players from 23 without any restrictions. So that's the probability that we end up with 3 defensemen. We'll just put 3D there. And so feed that into your calculator and make sure that you're doing the steps of Bedmas correctly. Now I'm going to get 0.311 here, and as a percent, that's going to give me 31.1% chance of that happening. So let's look at part B of this question and see what they're asking us to find here. Probability that at least one goalie will play in the golf tournament. Okay, so that's going to be a little bit different, right? We're being asked for the probability of X being greater than or equal to 1 goalie. When we're asked questions like that, we can do 2 approaches. We could figure out the probability of 1 goalie, the probability of 2, and the probability of 3 goalies being selected, and we could add those answers together. A shorter, more concise way of doing it is to think about what can't happen in a case like this. The only thing that we can't have is 0 goalies. And so if I take 100% probability and minus the probability that we have 0 goalies on the team, that should give me the complement, which will be the probability that we have 1, 2, or 3 goalies on the team, because we only have 3 goalies to choose from. So let's approach it that way. Let's look at it as 1 minus the probability of 0 goalies. And that means that we just have to put in 1 minus. And so out of the goalies, we had 3 to choose from, and we're going to choose 0. That means from the remaining 20 players, we have to choose all 8 of our tournament golf team members. And again, the total ways of just randomly choosing 8 people from 28 is 28 choose 8. That gives me an answer of 1 subtract 0.257. And so the probability of there being at least 1 goalie, so 1 or more goalies, is 1 minus that value, and we end up with 0.743, or 74.3% chance that we don't choose any goalies for our golf team. When we're asked for the expected number for hypergeometric and the next topic, which is binomial probability distribution, we can just use the shortcut formula for the expected value, which is n times p. And so in terms of the number of forwards, we need to know the probability of choosing a forward, and we need to know the number that we're choosing. The probability of choosing a forward is 13 out of the 23 players. We're choosing 8 players total for our golf team, and so our expected value is 8 times 13 over 23. And so if we multiply that, and keep in mind that when we find an average, it doesn't matter whether it's discrete or not. It doesn't have to be a number in our data set. We know we can't really have 4.52 forwards because we can't cut people in half, but that's the expected value, or the average number of forwards that we would expect to see on the team. For our last question today, we have a deck of cards, contains 20 cards, 6 are red, 14 are black. This is like the marbles question. We're withdrawing 5, and when we see without replacement, we know that we are doing hypergeometric probability. So what is the probability that exactly 4 red cards are chosen? So the probability of 4 red, we can write it like that, means that from 6 red cards, we would have to choose 4. There's only 1 card left to choose, and that has to come from the pile of black cards, so 14 choose 1 there. And then if we were just randomly selecting and we didn't care what color of card we had, we would have 20 cards to choose from, and we would be choosing 5. That's what makes it a probability, dividing by the total number of ways to choose 5 cards from 20. My calculator says that this probability is 0.013, I guess rounding off to 0.14, or a 1.4% chance of that happening. So this is just a day for us to get a little bit more practice and get a little bit more expert at solving problems like this. Please have a look at the worksheet, check your answers as you're going along, and make sure that you would be able to answer any questions of those types if I gave them to you on a quiz or on a unit test.